In number one, we're going to talk about quadratic functions. So here's a quadratic function in standard form. The quadratic function has vertex hk, all right, that's the vertex. So if the quadratic function's in standard form, we can get the vertex just by looking at this number and this number. And then let's look at the significance of a. If a is greater than 0, that means that the quadratic function, the graph, faces up. And a less than 0, negative, and the quadratic function faces down. Now, if we have a quadratic function where everything's multiplied out, let's say it's in this form, then from this form we have a formula for the vertex. The x-coordinate of the vertex is negative b over 2a. So the vertex is at x-coordinate negative b over 2a, and y-coordinate whatever we get when we substitute into here. All right, so let's say we call this, instead of y, f of x. This is more convenient notation, so we can denote what we get when we substitute in minus b over 2a. In number 2, we're asked to find the vertex. So we start with minus b over 2a, the x-coordinate. All right, so that's equal to, here's b, 6. So we have minus 6. Here's a. So we have minus 6 over 2 times 3. Minus 6 over 6, that's negative 1. All right, that's the x-coordinate. To get the y-coordinate, we're just going to substitute in. I'm calling this f of x now, using that notation. So f of minus 1 is equal to, just substitute in here, minus 1 for x squared. So we have minus 1 squared plus 6 times minus 1 plus 5. All right, so that would be 3 minus 6 plus 5. That's negative 3 plus 5 is 2. So that gives us a vertex of negative 1 for the x-coordinate and 2 for the y-coordinate. In number 3, we're going to graph this quadratic. So step 1 is to find the vertex. So we'll start with minus b over 2a. So that would be minus 12 over 2 times negative 2. Sorry, so that's minus 12 divided by negative 4, so that's 3. Now let's substitute 3 in. Let's say if we call this f of x. Okay, let's look at f of 3. All right, and we have minus 2 times 9 plus 36 plus 14. That's negative 18 plus 36 plus 14. That's 18 plus 14, or 32. So we found the vertex, and it's at 3, 32. We also should observe right away that since a is less than 0, that is the coefficient of x squared is less than 0, that means it faces down. Okay, with the vertex and the fact that it faces down, we can do an approximate graph. So let's do that here. And I'm not going to draw this to scale. Okay, so let me just say that 32 is up there. Here we have, let's say that's the point 332. And we're going to draw something that faces down. Let's get some points in here. Let's say y-intercept and x-intercepts, and so we can draw a better graph once we find those. For the y-intercept, we set x equal to 0. So if we set x equal to 0, we get this cancels, and we have y is equal to 14. For the x-intercepts, we set y equal to 0. So we're going to have minus 2x squared plus 12x plus 14 equal to 0. Let's factor out that negative 2 before we try to factor. So here we'll have x squared minus 6x minus 7. So this factors as x minus 7x plus 1. So we get two x-intercepts, x equal to 7, x equal to negative 1. All right, let's see if those look like they fit our graph. Okay, so we have a y-intercept at 14, so that would be about a little bit below the middle here. Okay. So that's the y-intercept, 0, 14. And intercept 7, say here, and negative 1. Okay, so that looks like it's enough information for us to draw a graph, and it looks like the intercepts are correct. And that's our graph. In number 4, we want to find the quadratic function with vertex negative 3, 2, and passing through this point. So we're going to write the general form of the quadratic function, that is the standard form. So that's ax minus h squared plus k. And here's the vertex. We'll put in for this is h, and this is k. So we'll just put in a minus 3 over here, and we'll put in a 2 here. So that's a, and here we have x, subtract minus 3, plus 2. Okay, so of course we're going to write that as x plus, sorry, there's a square here. Of course we'll write this as x plus 3 squared plus 2. So now what we need to find is a, and that's why we were given this point. So we're going to fill in for x minus 2, and for y we'll fill in 4. Remember, f of x and y are the same. So let's write 4 is equal to a minus 2 plus 3 squared plus 2. So 4 is equal to a, and here we have 1 squared plus 2. 4 is equal to a plus 2, and just subtract 2 from both sides. And we have that a is equal to 2. So now we can finish our quadratic function. Let's just write it over here. And we have f of x is equal to a is equal to 2 x plus 3 squared plus 2. And number 5, we have a quadratic equation in this form, and we want to find the x and y intercepts. So first, for the x-intercept, we'll set y equals 0. So that is 0 is equal to minus 2 x plus 5 squared plus 8. All right, let's put this on the other side. So that would be 2 x plus 5 squared is equal to 8. So basically I just added this whole thing to both sides. Now divide both sides by 2, and we have x plus 5 squared is equal to 8 divided by 2, which is 4. Now square root both sides, and we have x plus 5 is equal to plus or minus 2, and we'll split that up. X plus 5 is equal to 2. X plus 5 is equal to minus 2. And we have one x-intercept. X is equal to negative 3. That's 1. And x is equal to negative 7. That's the other. And now for the y-intercept, we'll just set x equal to 0. So we have y is equal to negative 2. 0 plus 5 squared plus 8. So that's negative 2 times 25 plus 8. Negative 50 plus 8, which is negative 42. So that's our y-intercept. In point form, this would be 0 comma minus 42. And the x-intercepts would be minus 3, 0, and minus 7, 0.